welcome to my channel, and in this channel we will be discussing the chemistry topic related to the solution. What is solution? Actually, solution is a homogeneous mixture of two or more components. यानी कि सॉल्यूशन दो और तीन कंपोनेंट को मिक्स करके प्रिपेयर किया जाता है. सो व्हाट इज सॉल्यूशन? सॉल्यूशन इज ए होमोजेनियस मिक्सचर ऑफ टू और मोर components. Now, depending on the number of components present in the solution can be classified into different categories, just like binary solution, ternary solution, quaternary solution, etc. So from the term binary, we can say that this is the solution which is made up of two components. That means जो solution दो component के mixture में prepare किया जाता है उसको कहते हैं कि binary solution. So binary solution meaning that the solution which is actually prepared by mixing two components. And ternary means three. That means the solution in which three components are present, or which is actually made up of three components, they are known as the ternary solution. So what are the quaternary solution then? Quaternary solutions are those solutions which are prepared by dissolving four components with each other. They are known as the quaternary solution. So I hope that this binary, ternary, quaternary, all of you have understood. And see, in this chapter you have to read mainly about the binary solution. Okay, so binary means this is made up of two components. One component of the binary solution is known as what? The solute, and another is called what? The solvent. Solute means the substance which is present in less quantity. Which is present in less quantity in a solution is known as the solute. So solvent, what is called solvent? Solvent means this is the substance which is present in large quantity and which determines the physical state of the solution. So that is known as the solvent. Suppose if I considered a solution is prepared by dissolving 20 gram salt in 100 gram water. 100 gram water. So in this solution 20 gram salt is the solute and 100 gram water is called solvent. Simultaneously, let me give another example. Suppose someone is saying that the 80% ethyl alcohol solution in water. 80% ethyl alcohol solution in water. So what is the solute here and what is the solvent? Actually, the 80% ethyl alcohol solution in water, it means that in the solution there are total 80% ethyl alcohol. So obviously 20% water will be present. Okay, so that means the ethyl alcohol which is present in large excess quantity, which is also liquid, and the solution is also liquid. So we can say that the 80% ethyl alcohol in this case is a solvent and water will be the solute. I hope that all of you have understood what is solute and solvent. Okay, now we will be moved to the next topic, that is the concentration of solution. Students, all of you have read this one in class 11, this part, concentration of solution. Then also you need to revise once again, because see, the many of the numerics will be coming from here. Okay, but these terms are actually needed to explain the next topic of this chapter, solution chapter, means to explain the colligative property. So this will be also one of the very important part, and many formulas and many things will be coming. So you need to understand each and every topic. Okay, so let us start with the concentration of solution. What is concentration of solution? Okay, concentration means the amount of solute present in specific amount of solution is known as the concentration of the solution. जाने कि suppose 100 gram solution you have taken. In this 100 gram solution, how much amount of solute is present? That is known as the concentration of solution. And for expressing concentration of solution, various methods are available. So one such method is that the mass percentage concentration of solution. Then second method, it will be volume percentage concentration of solution. Third, it will be mass by volume percentage concentration. Fourth, it will be the molarity. Next method of expressing concentration of solution, it will be molality. Then it will be coming another topic, that is normality. Afterwards, the mole fraction, another important, ppm, whose full form is parts per million. So these are the various methods of expressing concentration of the solution. Okay, so what is mass percentage concentration? Mass percentage concentration of solution. Mass percentage concentration of solution, it means the amount of solute or the mass of solute which is present in 100 gram of solution is known as mass percentage concentration of solution. Okay, so let me take see, mathematically we can say that suppose there is a solution whose mass is W gram, and let us take that this W gram solution contains m gram solute. So 1 gram solution will contain how much amount of solute? M by W gram solute. Then 100 gram solution, it will contain how much? Then M by W into 100. So by the definition, this is the mass percentage concentration of solution. Okay, so we can write this one, the mass percentage concentration of solution equal to mass of solute by mass of solution. Mass of solution means the mass of solute plus mass of solvent. Here you need to concentrate. I have seen many times instead of mass of solution, students have put the value of mass of solvent. Mass of solution means mass of solute and mass of solvent total mass. Okay, so here when you will be doing the numerics, you have to remember this is the mass of solution. That means जाने कि solute and solvent दोनों को add करना है to get the mass of solution. So this is the mass percentage concentration. So another one, next it is coming the volume percentage concentration. What is volume percentage concentration? Volume percentage concentration means generally this term is used to express the concentration of a solution whose both the components are liquid. The definition, it will be like this: the volume of solute present in 100 volume of solution, and this 100 volume, it means it may be the 100 liter or it may be the 100 ml. So similar way we can write the formula of mass volume percentage concentration of solution equal to the volume of solute divided by volume of solution into 100. Okay, so this is the volume percentage concentration of solution. Now another term is coming, that is the mass by volume percentage concentration. And what is this mass by volume percentage concentration? Students, here you have to remember, generally this method is used to express the concentration of a solution in the medicinal industry. And if you go to a medicine shop and if you buy a bottle of the syrup, then you can see that it has been written, suppose the 20 gram per 100 ml. It means that is the mass by volume percentage concentration is expressed. So this mass by volume percentage concentration can be expressed like this way: the mass of solute present in 100 volume of the solution, or it may be the 100 ml or it may be the 100 liter, etc. So mass by volume percentage can be calculated by this formula: mass of solute dissolved in the solution divided by volume of solution into 100. So this is the mass by volume percentage concentration of a solution. So students, I hope that you have understood about the mass percentage concentration, volume percentage concentration, and mass by volume percentage concentration of the solution. Now the next topic is coming, molarity. Very important. Many numerics. Also see, this term is very important to understand the colligative property, which will be discussed in the next part of this chapter. So first of all, you need to understand what is molarity. Number of moles of solute present in 1 liter of a solution is known as the molarity. Okay, so what I have said, once again, जरूरत पड़े तो नोट कर लो. If you want to write, if you want to note down, you can note it, but need to understand what is molarity. The number of, once again I am saying this one, I am repeating this one, what is molarity? Number of moles of solute present in 1 liter of the solution is known as the molarity. Okay, so let us consider that there is a V liter solution, and this V liter solution contains n moles of solute. Let us take that the V liter solution contains what? The n moles of solute. So 1 liter solution will contain how much moles of solute? N by V moles of solute. So by definition यही तो molarity है. So what we can say, this is the, by definition this is the molarity, and this is denoted by capital M. So M equal to N divided by V. N stands for number of moles of solute and V stands for volume of the solution in liter. Okay, so this can be a formula to calculate the molarity. Now see, you know that sometimes the volume of the solution will be expressed in ml. So 1 liter equal to 1000 ml, we know this one. So if the volume is expressed in ml, so then we can write here the molarity of a solution can be calculated by this: number of moles of solute divided by volume of solution in ml and multiply here 1000. So because 1 liter equal to 1000 ml. So how it is coming? How it is coming that we have to multiply 1000 here? You know that, let us consider that there is a VML solution. So VML solution means how much in liter? So we know that 1000 ml equal to 1 liter. So 1 ml equal to 1 by 1000 liter, and then VML equal to, then it will be what? The V by 1000 liter. Okay, so here this VML means this is coming what? The V by 1000 liter. Understood or not? I hope that all of you have understood this one. So V by 1000 liter, now it contains what? N moles of solute. So 1 liter will contain how much then? N by V divided by 1000 means jane ki 1000 it will be coming in the numerator. So I hope that all of you have understood that how this formula is coming. So molarity also can be calculated by this formula where the V is in ml, then multiply here 1000. And one more things you have to keep in mind, the number of moles of a substance can be calculated. So number of moles of solute can be calculated by this formula, that is equal to what? The W divided by M1. Let us take that this is W1, this is M1. W1 means this is the mass of solute dissolved in the solution, and this is the molecular mass, gram molecular mass of the solute or the molar mass of solute. So that is the number of moles. So if you substitute this N in this formula, then we will be getting another formula to calculate the molarity, that is equal to what? The M equal to W1 divided by M1 into V into 1000. Okay. Now one more thing you have to remember, see, the molarity depends on the volume of the solution. Since the molarity depends on the volume of the solution, and you know that volume can be changed with change in temperature. So for a given solution, the molarity of the solution will be changed with change in temperature also. Okay, that means the molarity is a temperature dependent quantity. So we can calculate the molarity by this formula, M equal to W divided by M1 into V, when V will be in ml into 1000. Also see, we can calculate this one, the molarity M equals to number of moles of solute divided by volume into volume of solution into 1000, when the volume will be given in the ml. Okay, so sometimes the molarity and the volume will be given, so number of moles of solute or the amount of solute can be calculated from this formula. Okay, I hope that all of you have understood about the molarity. Next term, it will be molality. What is molality? Number of moles of solute present in 1 kg of solvent is known as molality. So let us take that there is a W kg solvent, and this W kg solvent contains N moles of solute. Then 1 kg solvent will contain how much moles? N by W moles of solute. So by definition, this N by W, that is the molality. And molality is denoted by small m. Okay, so small m equal to, it will be what? The N by W. Okay, and this W is in the kilogram. This is the mass of solvent. Now similar way, see, if the mass of solvent is expressed in gram, then we have to multiply 1000 in the numerator to calculate the molality of the solution, when the W will be in the gram. And see, the number of moles, in the earlier case I have said it can be calculated by the formula W1 divided by M1. So what it will be? The M equal to W1 divided by M1 into W into 1000. Okay, so here one thing you have to remember, the molality depends on the mass of solvent. Since mass is independent of temperature, so molality also will not be dependent on temperature. And one more thing, that molality is considered better for expressing concentration of the solution over molarity, because you know the for a molarity depends on temperature, and molality is independent of temperature. That's why see, for a given solution the molarity can be changed with change in temperature, but molality will never change. Okay, so the molality is considered better for expressing concentration of the solution over the molarity. Next, it comes here the normality. What is normality? Normality, it is the number of gram equivalent of solute present in 1 liter of the solution. Okay, number of gram equivalent, students, how can we calculate? We can calculate the number of gram equivalent from the equivalent mass. Okay, number of gram equivalent, if we take that the number of gram equivalent is n, so this can be calculated by this formula, given mass of the solute divided by the equivalent mass of the solute. That is the number of gram equivalent. And here in the normality definition, क्या बोला गया है? नॉर्मलिटी इसको कहते हैं, नॉर्मलिटी इज द नंबर ऑफ ग्राम इक्विवेलेंट ऑफ सॉल्यूट present in 1 liter of the solution. Let us take that I have a solution whose volume is V liter, and this V liter solution contains n gram equivalent solute. Then 1 liter solution will contain how much? That will be what? The n by V gram equivalent of the solute. So this is by definition normality, and it is denoted by capital N. Capital N equal to, then it will be n by V. Similarly, number of gram equivalent C we can calculate by this formula W by E. So can it be written here that W divided by E into V, when V is in liter. Now again see the V, if it is given in ml, so obviously it should be what? The W by E into V into 1000. I hope that you have understood the term normality, and here also normality depends on the volume of solution. So as the normality depends on the volume of solution, so normality also can be changed with the temperature. Okay, so I hope that all of you have understood the term normality. Next term we will be discussing here, that is the mole fraction. Mole fraction. What is this? Suppose two solutions are made up of one solution is made up of two components. Let us consider that a solution is made up of the components by components are present in the solution is A and B, and let us take that the number of moles of the component A is present here, the Na. Simultaneously the number of moles of component of B is present is Nb. So total mole of solute component present in the solution, and what it will be? Na plus Nb. Now if we want to calculate the mole fraction of any particular component, so the mole fraction, obviously see it will be the fraction of one component, it appears always. So mole fraction of any component of a solution or the mole fraction of a of one component of the mixture, it will be the ratio of the number of moles of that particular component to that of the total mole present in the solution. So this is denoted by a Greek letter that is called chi. And suppose if I consider that we want to calculate the mole fraction of the component A, so mole fraction of the component A can be represented as the chi A, and chi A, it is the ratio of the number of moles of the component A to that of the total moles present in the solution Na plus Nb. Simultaneously the chi B, it will be what? The Nb divided by Na plus Nb. Okay, so chi A plus chi B, it will be Na divided by Na plus Nb plus Nb divided by Na plus Nb. So Na plus Nb, Na plus Nb here also it will be, so it will cut and it will be 1. So we can say that the sum of the mole fraction of each component will be equal to always it will be equal to 1. So once again, what is the mole fraction? This is the ratio of the number of moles of one component to that of the total moles present in the solution. Last concentration term, that will be what? ppm. ppm means full form is parts per million. It can be defined as the number of parts of solute present in millions parts of the solution. So this can be in terms of the mass of the solute or maybe the mole fraction of solute, etc. Generally, this method is used to express the concentration of a solution where the traces amount of solute is present. So that means parts per million, ppm, can be calculated by this formula, the parts of solute, or if we take it in the form of mass, mass of solute divided by mass of solution into 10 to the power 6, यानी कि 1 million, 10 to the power 6. So generally this is used where the traces amount of solute is present. So I hope that all of you have understood the concentration term. Last concentration term, that will be what? ppm. ppm means full form is parts per million. It can be defined as the number of parts of solute present in millions parts of the solution. So this can be in terms of the mass of the solute or maybe the mole fraction of solute, etc. Generally, this method is used to express the concentration of a solution where the traces amount of solute is present. So that means parts per million, ppm, can be calculated by this formula, the parts of solute, or if we take it in the form of mass, mass of solute divided by mass of solution into 10 to the power 6, यानी कि 1 million, 10 to the power 6. So generally this is used where the traces amount of solute is present. So I hope that all of you have understood the concentration term. If you have any problem to understand the concentration term, you can write in the comment section of this video. I will give the answer and I will clear your doubt. Now, in the next video, I shall start the topic, the solubility. That means the next topic of this chapter. So if you like this video and if you have got any type of help, so you can subscribe my channel, you can share with your friends, and if you have any doubts, so you can actually write in that comment box. I shall contact with you and I shall obviously give you the reply, and also I will try to make your doubt clear. And this channel actually I have created basically to help the students. Okay, so I hope that if you have positive feedback, so it will encourage me to make more video. That's all. Thank you. And in the next video, obviously we will be discussing the topic, the solubility. Tata. Bye bye.